Okay, today we are start third chapter, that is Raman Spectroscopy. So here we discuss the topic. First topic is what? The quantum and classical theory of Raman effect. Second topic is pure rotational Raman spectra. Third is what? Vibrational Raman spectra. Fourth is polarization of light and Raman effect. And last one is what? Structure determination from Raman and IR spectroscopy and its application. We already covered two chapters, that is rotational spectroscopy and your vibrational spectroscopy. In that types, we study transitions and emissions, selection rules, and all the things in detail. Just FTIR and its advantages, small topic is remain. I just make a video in next few days and post it on groups. So here we are starting our second video, that is Raman spectroscopy. This is a very conceptual topic and little bit difficult to understand, but I tried to make it simple for you guys. Raman spectroscopy is basically results from the light scattering phenomena. Here I written down some lines, which is basically the applications of the Raman spectroscopy. You will read it out or take a screenshot of this page. Okay, so just I written here that Raman spectroscopy yields information about intra and intermolecular vibrations and can provide additional understanding about reaction. So these are some applications of Raman spectroscopy. It is also used in the reaction analysis studies. Okay, so Raman spectroscopy is name given wait just a minute. Okay, so for Raman effect, so C.V. Raman awarded the 1930 Nobel Prize in the physics. He is a very brilliant person. So in the end of video, I will discuss why color of sky is blue and cloud is white, it just think about it. Okay, we are starting with what? Scattering of light. Okay, that Raman spectroscopy is result from light scattering. So basically, before starting the scattering of light, just remember throughout the video, this is useful to you. H nu naught is incident photon, that is incident photon energy is H nu naught, and scattered photon has H nu naught prime. We denoted by this H nu naught for incident photon, H nu naught prime for scattered photon. Just remember this. So what is scattering? When we pass the incident photon of energy H nu naught through molecular or material medium. So we are studying here the molecular spectroscopy. Just remember here, when we passing the H nu naught through molecule, the light gets scattered. This is what the simply what the scattering. So there are two major types of the scattering, that is elastic scattering and inelastic scattering. Inelastic scattering. Okay. So what is elastic scattering? In short, I just briefly here discuss. Elastic scattering means there is no change in energy. Okay, there is no change in energy, and here inelastic scattering means what? Change in energy, either lower or higher. Okay, so elastic scattering is also called as Rayleigh scattering, and inelastic scattering is also called as Raman scattering or Raman effect. So basic principle behind the Raman spectroscopy is what? Your inelastic scattering. So mainly we are interested in what? Inelastic scattering. Okay, so it is discussed in detail below. Okay, so here Raman effect can be studied using the two theories, that is quantum theory and classical theory. In quantum theory, we discuss the three cases. That three cases divided into two major types, that is elastic scattering and inelastic scattering. Elastic scattering is alone one case, and inelastic scattering, there are two cases from which we get the information about Stokes line and anti-Stokes lines. Okay, so we come back again here. So first of all, we are started with elastic scattering. Before start with elastic scattering, we need to understand certain terms. Okay. Basic difference between the Raman spectroscopy and all other techniques are what? In all other techniques, we study the transition and emission, suppose rotational spectroscopy, vibrational spectroscopy, and all other forms of UV visible. In that, we study basically the transitions and emissions. Okay, but in Raman spectroscopy, instead of, we did not study the transition, but as usually earlier said that Raman spectroscopy is result from what? Light scattering. So here we measure the scattering. Okay, in Raman spectroscopy we measuring the scattering. Okay, this is the basic difference between all other techniques and Raman effect. So in elastic scattering, what has happened is when we pass stream of particles that with incident photon h nu naught through the molecule, okay, we get we get the same energy, same radiation, that is h nu naught prime is equal to its original incident photon energy, that is h nu naught incident photon energy. So we get the same energy. So it is called as elastic scattering, or more fancy term, that is Rayleigh scattering. Okay, so here we how this happen will be discussed using this diagram. We know that in earlier chapter we discussed that suppose we take the two vibrational levels. Okay, V equal to 0 and V equal to 1. Upper level is called as J prime, and lower all J double prime. That is one vibrational level contains many rotational levels. Suppose this is V equal to 0 contains many rotational levels, and this is first excited vibrational level also contains many rotational levels. We called it as J prime, and lower is called as J double prime. So under one electronic level there are many vibrational levels. Okay, so this is this capital E naught is ground state electronic level, and this is this capital E1 is called as first excited electronic level. In between these two levels, a state is observed, higher energy state is observed, called as virtual level. This virtual levels means what? So as usually from the quantum mechanics, when photon interacts with the molecule, okay, photon interacts with the molecule, then molecule may be advanced to the higher energy state, which is called as virtual state or imaginary state. We can or it is short-lived state. So molecule from that short-lived state again come back to the below, okay, either ground state to the first excited state. Okay, first this is understand what is virtual level. Then from quantum mechanics we can say that when photon interacts with molecule, then molecule is advanced to the higher energy state, and this is a virtual state, or we can call it as short-lived state. Okay, or imaginary line. In simple language, just imaginary line. Okay, so how the elastic scattering is happen when h nu naught of energy is passed through molecules. Let's suppose 100% of h nu naught is passed through molecule, and we get 99.99% scattered radiation. Okay, so it is nearly equal to the 100% energy. That is, we can say just 0.001% energy is interacting with molecule. Means it is almost negligible. That's why we can say h nu naught equal to h nu naught prime. So that is incident energy is equal to the scattered energy, that is same. So this phenomena is called as elastic scattering or Rayleigh scattering. This is the first case. Okay, then we'll come to our next important topic, that is inelastic scattering. That is basic principle behind the Raman spectroscopy, or we call it as Raman scattering or Raman effect. In this topic, two main cases are observed. That is, first is Stokes line, and that is second one is what? Anti-Stokes line. First we'll study about the how the Stokes lines appear using this diagram. Okay, just concentrate here. This is your ground state electronic level. This is your first excited state electronic level. This is virtual state. Okay, when molecule is in the ground state, okay, population is more. Okay, here according to the Boltzmann distribution law, population is there. So in this case we are started with ground state. When incident photon of energy hits on the molecule from the ground vibrational level excited to virtual state, and it again come back to the first vibrational level, that is V equal to 1. So here we can say there is certain amount of energy spent with molecular interaction, means here molecule energy is increases and radiation energy is decreases. Means suppose we are passing 10 10 not okay 20% of the energy, and suppose 5% is spent in molecular interactions, so remaining is what, 15. Okay, so radiation energy is what, then 15, and 5 is what, your molecular energy. Now just so here we say that scattered energy is less than scattered energy is less than your incident energy, because some energy is lost in what, molecular interaction. Means here molecular energy decreases, molecular energy increases and radiation energy decreases. So definition of Stokes line is what, your radiation scattered with frequency lower than that of incident photon, that is h nu naught prime is less than what, h nu naught. Don't confuse here, just we are, for simplification I just considering that figure 20 and all. Just here just remember that when we pass incident photon energy through a molecule, then a molecule goes from ground state to the virtual state, and it again come back to the first excited level. So somewhat energy is spent. So scattered photon has less energy than your incident photon, and that spent energy is gained by what, your molecule. So molecular energy is here increases. So this case is happen after the interaction with molecule, and this referred as Stokes line. So in this case we got what, Stokes line, and here we show that V equal to 0 to V equal to 1. So again concentrate here, when we pass radiation, then molecule goes to the ground state to this virtual state, and it again come back to your first excited layer instead of ground state. So this gap is called as your Raman shift, denoted by delta E. This is called as your Raman shift, that is not given in your book. Okay, so delta E is what, E final, that is this upon E initial. This is called as Raman shift. Okay, so basically again I repeat that radiation scattered with a frequency which is lower than incident wave, that is h nu naught prime is less than h nu naught, is called as your Stokes line or Stokes scatter, we can say. Okay, so here I have shown that what it is. Okay, h nu naught prime is what, your scattered photon energy. H nu naught is what, incident photon, minus delta I, because this amount of energy is spent with molecule interaction. Means this much amount of energy is gained by what, molecule. So energy is decreases here. Initial energy is high, and then after interaction this much energy is remains. So this comes to the negative side, that is in this case energy decreases. So frequencies also decreases, that according to your fundamental equation E is equal to H nu, that E is proportional to V. So we can say as energy decreases, frequency of scattered photon is also decreases. So due to this, when this decrease is observed, this is called as your Stokes line. Okay, this is all about the Stokes line. And in next case, just reverse is happen. What it is, with I will explain with the help of diagram again. In this case, what happen is molecule is in first first excited state, that is first excited vibrational level. From here, first excited level, molecule goes to your virtual state, and then in it come back to the ground vibrational level. Just see here is what from molecule goes to the goes from first vibrational level to the virtual state, and here it comes back to the ground vibrational level when we hit the incident photon on a molecule. Just remember here. Then then again we get the scattered photon, that is h nu naught prime. But the basic difference in B and C is what? Here energy is decrease. Okay, here energy is decrease, but here from the diagram you will clearly see that energy is what? Here increase. Suppose initially this is 10, and after interaction the energy is increase. Suppose it is increased by suppose 5. Okay, suppose it is 15. Just for understanding, this is suppose 10, and after interaction scattered photon energy is increased by certain amount. So this increase is responsible to give a line called as anti-Stokes line. So here we can say h nu naught prime is equal to h nu naught initial, that is incident, plus increase in energy plus delta E, means this much amount of energy is increased. So we can say that what it is, what is scattered photon frequency is higher than incident photon frequency. So here just case observed is what? H nu naught prime is greater than your H nu naught. So here we observe the anti-Stokes line. So what is definition? So radiation scattered with frequency higher than that of the incident beam is called as anti-Stokes line, which is shown in the form of spectra. So you will clearly see that. Okay, here I mentioned what? Nu naught bar, nu A bar, and nu S bar. Okay, just here concentrate here more. This black line, okay, highest intensity line is for Rayleigh scattering. So here is what? Your H nu is equal to H nu naught prime. Okay, here both energies are same, the scattered photon and incident photon. So in case of Stokes line, what happen is energy is decreased. So this is this is for the Stokes line, and here energy is increased. This is for anti-Stokes line. So this is we can say this is from positive side, and this is for your negative side. Suppose and this gap is equal. Okay, here, wait, this is what your delta E, and here is also your delta E. So this gap is between Rayleigh scattering and Stokes line, and Rayleigh scattering and anti-Stokes line. This gap is same. Suppose in Raman spectrometer we get the spectra. So this gap is same. Then suppose this is plus 10 and this is suppose your minus 10. Suppose the Rayleigh scattering frequency is suppose 200, then this is 100, and this is your 300. Okay, are you getting what I'm saying? Suppose this Rayleigh scattering wave number is what here? Suppose 200, this is 100, and this is suppose 300. Just consider this is less than Rayleigh scattering, and here it is greater than Rayleigh scattering. So we can so trend is what? Energy in the form of what? Wave numbers according to the this equation, that is E is equal to H C nu bar. So E is proportional to your nu bar. So energy is considered here in the centimeter inverse. So trend is what? Your